Let's talk substitution in systems of equations. I'm Jesse from Capstone Academics, and today we're going to talk about the 9 problems you need to be ready for when substituting in systems of equations. We're going to start off nice and easy and just work our way up. Be sure to stay with us till the end because I designed a 2-problem test for you guys that if you can pass it means you're pretty much ready for whatever you're going to see. So let's get started. You'll want to use substitution when one variable is either already isolated or really easily isolated, like we have with this y here. So if you look, we just have y equals 2x plus 1. You can take the 2x plus 1 and just pop it in for that y down there. So make sure when you plug these in, you are using parentheses because a lot of times the coefficient in front is going to need to distribute in like we're going to see here. So I'm just going to finish copying this. When we distribute the -3, it's going to look like this. It's be 8x minus 6x minus 3 equals 5. Now, always look to combine like terms before moving anything to the other side of the equation. So before we move that 3 over, we'll combine the 8x and the 6x and get 2x, bring the 3 down. And now we can just add the 3 over and start solving. So we have 2x equals 8, divide both sides by 2, and x is 4. Now that we have what x is, we can take that and plug it into the easier of the 2 equations for you to get y. Now, if you look at these two, like which one would actually be easier for you to get y? And it would definitely be the top one because y is already isolated. So if you take the 4, pop it in right there, I'm going to write my work down here. So y equals 2 times 4 plus 1, y equals 8 plus 1, and then y equals 9. And that's our solution. Remember, for a system of equations like this, you write the solution as a point because it's the point where the two, let me write it over here, where the 2 lines actually intersect. So these two intersect at 4, 9. So let's just say the lines look like this. So it'd be like 4, 9, and that's where these 2 lines meet. So that's the solution. Moving on to our next example here, we actually have something kind of tricky, and I made this one to illustrate this one sort of trap that kids tend to fall into. When you take what y equals, the 2x plus 1 in this case, and then plug it into this y here, a lot of people forget to distribute this negative. So we're going to talk about how that looks. It's just 3x minus, and then again, use those parentheses, super important. And then you've got a -1 that's distributing to this. So then 3x minus 2x minus 1 equals 3. Combine the 3x and the -2x. 1x minus 1 equals 3. Add the 1 over. X equals 4. Not a problem. Choose the easier of the 2 equations to plug this into. So the 4 into that one, I think, right? Because the y is already isolated, it's much easier. So 2 times 4 plus 1, 8 plus 1, and then y equals 9. So remember, these are expressed as a point, 4, 9. That's it. Okay guys, so this one. Sometimes x is going to be the variable that's isolated, so you just have to be ready for that. So since x equals 2y minus 6, take the 2y minus 6 and plug it in for the x in the other equation. Make sure to use parentheses, and then you'll end up distributing. I'm just going to write the whole thing out first. So you get this. Distribute the 3. 6y minus 18 minus 4y equals -10. Combine those like terms before anything else happens. 6y minus 4y is 2y. Bring down the -18. Add the 18 over. 2y is 8. Divide both sides by 2. Y is 4. Take the 4, plug it back into the easier of the 2 equations, which is always going to be the one with the variable isolated, if you have one, right? So plugging it in there, x equals 2 times 4 minus 6. X equals 8 minus 6. X equals 2. Expressed as a point, we've got 2, 4. And that's it. Okay guys, so for this one, they both equal y, so it would kind of make sense that they both equal each other, right? Like 3x plus 6 just equals 2x plus 4. So that's one way you could look at it, or you could just be like, okay, well y equals 3x plus 6, so take the 3x plus 6 and plug it in for the y in the second equation. So 3x plus 6 equals 2x plus 4, and then just move the 2x over to the left side, get the x's together. So 1x plus 6 equals 4, and then subtract your 6 over, and x is -2. Now we'll take the negative 2 for the x and plug it into the easier of the two equations. This is really your call. Usually the one with the lower multiplier is better though, so I'll just plug it in there. So like y equals 2 times negative 2 plus 4, y equals negative 4 plus 4, and then y equals 0. So easy enough, and expresses a full point, negative 2, 0. And that's all. Guys, if you're finding this helpful, please do go ahead and hit the like button. Thank you, and stay tuned for some really important stuff coming up. If you can get through this stuff, you can get through just about anything. Okay guys, so for this situation, sometimes there isn't a variable that's isolated already. You're gonna have to isolate one yourself, and it just takes a little bit of algebra. So you just wanna look at all 4 of the variables, right? So like this one, the x here, the y here, the y here, and the x here, and just ask yourself which one is most easily isolated. And it would definitely be this x down here, because all you're going to have to do is just divide both sides by negative 2, and then that x will be by itself, so that you can then take what it equals and plug it in for the x in the other equation. So we're going to erase all that kind of stuff there. And like we said, we're just going to divide both sides by negative 2 to isolate that x. When you divide this side by negative 2, make sure you divide both the terms by the negative 2. Super important. So I'm just going to switch things around so it's like x equals, and then 18 divided by negative 2, negative 9, and then negative 12 divided by negative 2, positive 6y. And now that I have what x equals, I can take what that is and plug it in for the x in the other equation. So you now have 4 times negative 9 plus 6y minus 5y equals 2. Distribute that 4, negative 36 plus 24y minus 15, or minus 5y, sorry, equals 2. And then combine these y's here, you're going to get 19y, and then you can bring down your negative 36 over here if you want, and then equals 2, and then bring the 36 over. So 19y equals 38, divide both sides by 19, and y is 2. Now we're going to take this, plug this into the easier of the two equations, which remember is the one with the already isolated variable. So this one right here. So we've got x by itself in this equation. That's the easiest one to plug the y into. So x equals negative 9 plus 6 times 2. So negative 9 plus 12. And then negative 9 plus 12 is 3. So full solution as a point, 3, 2. That's it. Okay guys, so for this one, y equals 2 is a horizontal line, so it looks kind of weird because there's no x in there or anything, but it just means we know the y coordinate like straight off the bat. So take the fact that y equals 2, plug it in right there, and you get 4x minus 5 times 2 equals 14. And then 4x minus 10 equals 14. Add the 10 over, 4x is 24. Divide both sides by 4. And x is 6. Now, remember how we already know that the y coordinate is 2? You're done. You just say that x is 6 and y is 2. That's all. This is the same kind of thing, but with x. So x equals negative 2 is actually a vertical line that's intersecting with this line. So we already know the x coordinate of the intersection point is negative 2. So just take the negative 2, pop it in for the x there. 3 times negative 2 plus 5y equals 9. Negative 6 plus 5y is 9. Add the 6 over. 5y is 15. Divide both sides by 5. Y is 3. Now, just like last time, we already have one of the coordinates here, like x is negative 2. So for your solution, negative 2 for the x, because you already know, and then 3 for the y. That's all. Okay, so we got to talk about no solution and infinite solutions, which I know is kind of hard and like a little annoying, but it tends to be what most people struggle with, so we definitely have to clear this up. So if you just start solving this like a normal system, like, oh, these are both y equals, so you can just take one of them and set them equal to the other, or plug the 2x plus 4 into the other y, and it ends up looking like this, and you're going to notice something weird happen when you try to combine the x's. You move the 2x over, and you're like, oh, both x's canceled, so now all I have is 4 equals negative 3. Just ask yourself if this is true or false. And this is false. So this is what creates the no solution situation. Now remember, for a system, a no solution situation just means that the two lines are parallel, so they never intersect. So it makes sense that if both variables cancel and you get a false statement, those lines are just never going to touch. So no intersection point, no solution. Infinite solutions is really, really similar. So you just take the 2x plus 4, plug it in for this y like you would normally go about your system solving, right? And of course you're going to try to get the x's together, but they're going to cancel again, right? But this time you have a true solution. So when the x's cancel and you end up with something true, it's just infinite solutions. Because it actually doesn't matter what x and y are. They cancel out anyway, and you still get a true statement, 4 equals 4. So the reason this is happening is, in case you didn't notice, these two guys are the same line. So if you graphed them, they would look like this, just like one on top of the other. So there's an infinite number of intersection points, and each of those intersection points is a solution, so infinite solutions. And now for the test. If you guys can crush this test on your own, then you should be ready for pretty much anything you're going to see. Okay, here we go. First problem. Now, if you guys look, this is kind of more set up for elimination, isn't it? But if your teacher says you have to solve this by substitution, then you have to, right? So you're going to be looking at all of these terms and just asking yourself, like, which one of these would be the easiest to isolate? Now, you want to look at the coefficients when you're doing this because you're going to end up dividing by whatever coefficient is in front of that variable when you're isolating it. So which one is the least dramatic to divide by? Probably the 2, right? Because if you divide all these terms by 2, you're not going to end up with any fractions, which is what we want. So I'm going to go ahead and isolate that x in the top equation. So we're going to do, I'm just going to copy it here for some more space, 2x plus 4y equals 10. Move the 4y over. First, I'm going to wedge it right here because having the term with the variable before that kind of looks more natural. You don't have to do that, but it's just what I prefer. So now you can just divide both sides by 2. Make sure you divide both of these terms by that. And then you get negative 2y plus 5 is what x is. So we have x successfully isolated. Now we're going to take this and plug it in for the x in the other equation. So it's going to go right there. Now 3 times negative 2y plus 5 minus 5y equals negative 7. Distribute the 3. Negative 6y plus 15 minus 5y equals negative 7. Combine these terms here. Negative 11y plus 15 equals negative 7. Move the 15 over. Negative 11y equals negative 22. And then I'm just going to bring this up here. Negative 11y equals negative 22. Divide both sides by negative 11. And y is 2. So now that we have what y is, we can take this and plug it into, remember, the equation that already has a variable isolated, which is this one that we made where we isolated x. So take this guy, plug it in right there. So x equals negative 2 times 2 plus 5. So negative 4 plus 5. So positive 1. And then full solution here is 1, 2. There we go. First one out of the way. Okay guys, last problem. So we're going to do the same kind of thing where we look at all of these terms and just try to figure out what the easiest one would be to isolate. Now, you've kind of got your pick here because you could isolate this x term up here, and that would be fine because all of these are divisible by 3. Or you could isolate this x term down here because all of these terms are divisible by 2. I'm going to go with the x term on the bottom just because we're working with lower numbers and I'm just trying to help you guys out with, you know, the very best, most efficient, and lazy strategies. So yeah, we're going to go ahead and do that. So isolating this x means moving the 8 over first. So negative 2x equals negative 4y minus 8. And then divide both sides by negative 2. Make sure to hit both of these terms with that division. So you end up with x is 2y plus 4. So that's what x is. Take the 2y plus 4 and then plug that in for this x right there in the other equation. So negative 6y plus 3 times 2y plus 4 equals 12. Distribute the 3. Negative 6y plus 6y plus 12 equals 12. Uh-oh, this looks suspicious, doesn't it? The y's are gone. 12 equals 12, but this is a true statement. So what is it when it's true? Is it no solution or infinite solutions? If it's true, it's infinite solutions. Because the equation is true regardless of the fact that x and y have disappeared. That's a wrap for Substitution, guys. If you found this helpful, please do go ahead and hit the like button. It helps me out a lot. Thank you. And subscribe for more math help all year long. I'll be churning out at least one video every week. If you'd like to meet with me for online tutoring or test prep for the SAT, the ACT, or others, check us out at capstoneacademics.com. And be sure to check out our full test, in-depth SAT walkthroughs there as well. And if you guys need help with elimination, go ahead and check out that video next. I'll put it on the end screen for you. Thanks so much, and see you next time.